So we're going to do the long way first. This is the long way. Now, there's a way to do this without having to do all this stuff. So, but let me try to help you guys understand it. The first thing you'd want to do is factor this thing. So you're going to go x minus 3 and then x plus 2. I'm going to ignore this right here. I'm just going to pretend it says equals 0. All right. So what you would do is you would solve this. You would get x equals 3 and 2. Right? Right? Yeah. No, negative 2. That's right. Okay. Now if I graph this, I would go to negative 2, and I would put a dot right here. That would be negative 2, and then I would go to 3, and I put a dot right there. Okay. Those are the x-intercepts. Okay. Now, if I were to graph this the quadratic equation, I know that we're not going to go up and down like this because it's not negative. It's a positive one. The leading coefficient is positive, so I would do something like this. Okay? And it would go through both the x-intercepts. Now, if I'm just looking at that, and then I'm looking at this, and this says, where is this less than 0? This graph right here represents this quadratic equation, right? So the question is, where is this less than 0?
Between -2 and 3.
Graphically, what's that question like? I mean, here it says, where is it less than 0? How would you say that for the graph? You would say, where is this below the x-axis? Here's the x-axis. All the y values below the x-axis, aren't those less than 0? Because that's what this results in. It results in the y values. And so all the values that are on the y-axis is this, right? So if I'm between negative 2 and 3, all those x values would make this less than 0, right? Oh. Okay, so your answer for this would be negative 2 to 3. Now, is it equal to or just less than? Because if I plug in negative 2, what do you get for the y value? You get 0. It's an x-intercept. That's what we found right here. We found the zeros. Negative 2 would give you 0. So if I plug in negative 2 there, and I plug in negative 2 there, I would get 0. Because negative 2 plus 2 is 0, and 0 times whatever you got over here would be 0, right? So negative 2 would give me 0, not something less than 0, so I'm not going to include that one. Yeah. The same with the 3. Here's your answer. So graphically, this says, where is this function below the x-axis? Because the x-axis is where y equals 0. Y equals 0 on the x-axis, and then it looks like the graph is below the x-axis right there. Okay? That's how you should understand this problem. Another way to write this answer is to say x is, you could say x is between negative 2 and 3. It's greater than negative 2 and less than 3. So that's how you would write it as an interval notation. And then for like a graph, like if I just did a number line at negative 2 and 3, that's right here. This is a number line. Here's negative 2 and here's 3. Not equal to 2, but everything greater than 2. Not equal to 3, everything less than 3. So we go like this. Okay, so graphically, I think this really helps us understand it. Now, how would you do this if you didn't want to graph it? Because there's going to be problems that you don't want to graph. Because it's like, whoa, that's a lot of work. This is how you would do it if you didn't want to graph it. So if you didn't want to graph it, or if you just thought that would take too long, then this is what you would do. You would take your two x-intercepts, the two zeros that you found, you throw them on a number line, you get negative 2 and you get 3. Now we saw this earlier, you guys remember this was the x-axis. And then what you would do, since you can't see the graph, you would test points. Now we have 3 intervals, this one, and this one, where we have to test. We have to test the intervals. So give me a number that's below negative 2, that's in this interval. Negative 4 or negative 3, whatever you want, okay? You can say negative 5, you can say negative 10, whatever you want to choose. Or give me one that's in this interval, and give me the easy number.
0.
Yes, 0. Yes, 1 is kind of easy, but it's not like 0. Okay, give me a number that's in between this, or that's in that interval.
4.
That's a 4. Okay, so now what you have to do is you have to test them. See if it's true for this. So let's try the negative 3 first. If I try the negative 3, it would go like this. It would be negative 3 raised to the second power minus negative 3, and then you go minus 6. Is that less than 0? I don't know. Let's see, we got 9 plus 3 minus 6. Is that less than 0? Doesn't look like it, because this is a 12 minus 6 is 6. 6 less than 0? No, it doesn't work. And so I'm going to X this foo out. That interval failed our test, so it is not part of the solutions. Let's try the 0. Now, I'm writing it out, but you can probably just do this in your head. Actually, let's do this one in our head. What is 0 squared? 0 minus 0, 0. So we have negative 6 is less than 0. Did 0 pass our test? Yes, it passed our test. So I'm going to circle him so I already know I tested him. And then I have a 4. Ooh, 4. What is 4 squared? 16. Now I'm going to write this out because I have multiple steps. And I have to subtract 4 minus 6. So this is going to be, well, this would be negative 10, right? And what's 16 minus 10? 6. Is 6 less than 0? No. So this one failed. So the only interval that passed was this interval. So then you're going to go from negative 2 to 3, and that's going to be your answer. Here's a couple vocabulary terms that you guys need to know. Now this is an interval. This is not a coordinate. Okay, it looks like a coordinate, just like a coordinate, but it's not. It's an interval. These numbers right here, these are called critical values. And I think that's it. This is called an inequality, blah, blah, blah.